Okay, this is set 8, but it's Wednesday. This is day 1. So we're going to start with number 1, which is an XY table. Guys, remember that our X is, if it's a horizontal table, our X is always on the top, our Y is always on the bottom because X comes before Y. So anytime we have a table, we're trying to figure out how did we get from X to Y. It's always, your equation is always going to be Y equals something. Something's happening to X that ends you up at Y. So if we look at the 4, we ask ourselves, how did we get from 4 to 24? How did we get from 5 to 30? How did we get from 6 to 36? Well, whatever that rule is, it has to be the same for the whole table, okay? So if we think about 4, we can just sing our 4 song. 4, 8, 12, 16, 20, 24. Well, that would be times 6, but if this is times 6, this has to be times 6. So 5, 10, 15, 20, 25, 30, that's times 6. This would have to be 6 times 6. 6, 12, 18, 24, 30, 36. So our pattern is times 6. So if we get over here and we're missing a Y, we know all we have to do is multiply 8 times 6. So 8, 16, 24, 32, 40, 48. So that's going to be 48. Our missing Y is 48. We know our rule. When you guys were in 4th grade, you learned to write this as a rule. So your rule is going to be times 6. Okay, but in the 5th grade, we're actually going to write the equation. Okay, so this is Y equals X, and what we did is we multiplied by 6. But when we write this, we really need to write it as Y equals, we need to put our coefficient first, and we need to have our variable last. And we need to, again, remember guys, if there's not a sign in between, we don't really have to put a multiplication sign. And one of the reasons we don't want to is because now that we're using an X, and that's a variable a lot, when you put a multiplication sign there, it looks like your X. So we use either dots or we use nothing. And really this is what it's gonna look like in 6th grade, okay? So is this pattern additive or multiplicative? Well, obviously it's not additive because we're not adding to get from X to Y, we're multiplying. And remember when we plot these, the slope, once we plot all of these coordinate points on our coordinate grid, when we draw them together, remember our slope goes straight through the origin. So anytime it's multiplicative, the slope that you draw after you plot all these is going to go through the origin, okay? All right, so number 2 is 7 divided by 1/3, or it says this means how many thirds are in 7. So how many 1/3 are in 7? Well, if you look at our model, we've got 1 here, we've got 2 here, we've got 3 here, we've got 4 here, we've got 5, we've got 6, and we've got 7. Okay, so here's our 7 whole. And remember, we have whole divided by fraction equals whole. So whatever our answer is should be a whole number. So if this is asking us how many thirds are in 7, we should be able to just count these. But before we do that, because our rule is do the math first, make it match the model. So if we have 7 divided by 1/3, okay, well first thing we have to do is we have to rewrite this 7 as a rational number. So we're going to need to put a 1 under it because we're going to want to turn it into a fraction. Now remember, we don't divide fractions. We multiply them, so we've got to keep, change, and flip this. So we keep our first fraction, we change our multiplication to division, and we flip. We do the inverse operation, we do the reciprocal of this, so it's 3/1. We multiply straight across. 7 times 3 is 21, 1 times 1 is 1. 21 divided by 1 equals 21. So we should, if we count these, we should have 21. So let's do that. We can count by 3s. We can actually sing our 3 song because there's 3 in each side. So 3, 6, 9, 12, 15, 18, 21. We do have 21. Did it fit our pattern? Whole divided by fraction equals whole. Yes, we got a whole number, so we're done. Okay, draw a model and solve the equation for the following problem. Scott is buying a new refrigerator for $832.32. He wants to make 12 equal monthly payments. How much will each payment be? So we're buying something for this much. We want to make this many payments equally. So what are we doing to this number? We're dividing it. So instead of drawing a model, we're going to do part whole, which is just better, I think. Which one of these is our whole? Well, obviously our 832 is our whole. Our part is 12. Either this is addition and subtraction or multiplication and division. Well, we know it's multiplication and division. We do not have both of our numbers to be able to multiply, so we know it's division. So we're going to take our 832, 32 divided by 12. All right, now, we usually round this number, and if we did, we would round it to 10. We don't really need to do that because we know our 12s. So we do have a decimal in our dividend, so remember the first thing we have to do is we have to float that bobber to the top, put it in your quotient. So how many times does 12 go into 8? Well, it doesn't. How many times does 12 go into 83? So we're going to say our 12s. 12, 24, 36, 48, 60, 72, 84. Well, that's too much, so we're going to have to come back to 6. Well, that 6 isn't going to go here because 12 doesn't go into 8 6 times. 12 goes into 83 6 times. Okay, and that was 72. So we write our 72. We subtract. 8 minus 7 is 1. Does our friend need help? No. So we write our 1. 3 minus 2 is 1. We check, make sure this is less than our dividend, which it is, barely. We bring down our 2, and now we're doing our 12s to 112. 12, 24, 36, 48, 60, 72, 84, 96, 108, 120. Well, 120 is too much, so it's going to be 9, and it's going to be 108. So we're going to put our 9. We're going to write 108. 11 minus 10 is 1, but does our friend need help? Yes, so we're going to put a 0 or nothing. We're going to give that 1 to our friend. 12 minus 8 is 4. We're going to bring down our next number, which is a 3. 12, 24, 36, 48. 48 is too much, so it's going to be 3. And 12 times 3 is 36. 4 times 3 is 1, but our friend needs help. 13 minus 6 is 70. We're bringing down our last number, 72. So we'll say our 12s again. 12, 24, 36, 48, 60, 72. So it goes exactly in 72 times, and that is a 6. So if we come back over here, the question was how much was each payment going to be? So our part that we were missing is $69.36. So the answer would be $69.36. Okay. It says circle all the names that could identify this figure. Okay, so the first thing let's do, let's mark this up. We know these two sides are congruent and parallel. We know these two sides are congruent and parallel. So is this a square? Well, we know the definition of a square is all 4 sides have to be congruent. So this does not match the description for square, so that's not going to be an answer. Is this a trapezoid? Well, no, because we know the definition for trapezoid is only one set of sides are parallel. Is this a polygon? Well, we know our polygon. Here's the definition. It says a closed plane figure formed by 3 or more line segments. So here's some examples. Okay, a polygon is a closed plane. That means this is not a polygon because it overlaps, right? And it has 3 or more line segments, so it can't have any curved lines. So that's why this is not a polygon. So either one of these are polygons. So is this a closed plane figure formed by at least 3 lines? Yes, it is. So it's a polygon. So our quadrilateral means that we have a polygon that has 4 sides. Quad means 4. 1, 2, 3, 4. So that fits. We've got a rhombus. Well, the definition of a rhombus is a polygon with 4 congruent sides. It's like a square, except for it's crooked. Well, this doesn't have 4 congruent sides. It has opposite sides congruent, so that's not going to be a rhombus. Obviously, it's a rectangle because that's what it is. A pentagon has 5 sides, so it can't be a pentagon. A parallelogram has opposite sides that are parallel. This does have opposite sides that are parallel. So those are the 4 names that could identify this figure. All right, we're creating a stem and leaf plot using this data. Always remember we look at our key first. The key tells us if we're looking at whole numbers or decimals. So the key says 9 and 3 means 93, so that means all these are whole numbers. So we're going to look at all of our data and say, okay, what's our lowest stem that we have? Well, I don't see any 30s, so it looks like 40 is going to be our lowest stem. So I'm going to put a 4. I've got a 45, a 45, a 45. That looks like all the 40s that, oh, nope, sorry, we have a 47. So I'm going to do a 5. I'm going to do another 5. I'm going to do another 5. And I'm going to do a 7. And I'm going to double check, make sure there's no more 40s left. So I'm going to do my 50s. I've got a 54, I've got a 55, a 53, a 54, a 51, a 56, and that looks like all. My lowest is a 51. My next lowest is a 53. Remember, we want to put our leaves right underneath so they're in perfect order. We've got another 4, or we've got our first 4, sorry. Then we have another 4. Then we have a 5. And then we have a 6. Okay, so our next stem is going to be a 6. And I've got a bunch of 60s, so let me circle all of them. All right, so our lowest one looks like it's 61, and we have 3 of those. So I'm going to go ahead and cross all those out, and I'm going to put 3 ones over here. Then I've got, don't have any 62s. I've got 2 63s, so I'm going to put 2 3s. I've got 2 64s, so I'm going to put 2 4s. And then I've got an 8, so I'm going to put 1 8. And then I've only got 1 76, so I'm going to put my 7 stem. I'm going to put my 6 leaf. And then I'm going to count my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So if I have 19 numbers, I should have 19 leaves. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.